So this annual award from SLAS, so the Society of Lab Automation and Screening, is to recognize insightful studies to develop new technologies for the lab or to use an existing technology to solve a unique problem. So I presented our Vortex technology for fast and label-free isolation of circulating tumor cells from blood. I shared our work on the transfer from this microfluidic research platform developed at UCLA in the lab of Dr. Dino Di Carlo to this commercial product, VTX1 liquid biopsy system. So liquid biopsy is an alternative to conventional tissues biopsies, which are very expensive, painful, and not always successful. Among these liquid biopsies, we have circulating tumor DNA, circulating tumor cells, especially are cancer cells that detach from the primary tumor, enter in the bloodstream of the patient, then they are going to stop at other organs of the body to create metastasis. And even more, they could be present in the blood before the detection of the primary tumors in the patients. That's why there is this excitement, this growing interest on these CTCs, as they could really provide a real-time vision of the cancer. These liquid biopsies really show you how the cancer looks like everywhere in the body. So it gives you much more information, much more accurate information than just a piece of tumor. The challenge is that these CTCs are very rare. You have only several cells surrounded by a background of millions of white blood cells and billions of red blood cells. So it's really like finding a needle in a haystack. It's quite challenging. Vortex is a microfluidic approach, so we don't use any antibodies, any chemistry. So you have these microfluidic channels where we inject the blood at really high flow rate. So we have some inertial microfluidics, and we have these vortices. And as the blood flows through these vortices, the larger cells, which are the cancer cells, will be trapped to these vortices while the blood cells go through. So they are not trapped in these vortices. And then we can wash, and while the cancer cells remain trapped in these vortices, and then we can release them off chip by just stopping the flow into this microfluidic chip. So basically we just take the blood tube, we connect the blood tube to this consumable, we put that into the instrument, and then the blood is processed and we just collect the cancer cells out of the chip. This offers significant advantages over these existing technologies. Recovery and purity are really high, which enables to have more material for your downstream assays. Our processing is purely microfluidic, so it's really gentle on the cells, so the cells remain intact, which again gives you more content for your downstream assays. The workflow is very simple, which enables a low cost per sample processing and also a high level of reproducibility. We don't use any label, so it's purely label free, so no chemistry, no antibodies, just microfluidics. We have a really high flow rate, so it enables high throughput, but also gives you flexibility to process large volume of blood, as well as small volume of blood if you need. Finally, the cells are retrieved in really small number, 300 microliters, in various containers, so it gives a high level of flexibility to the user to do whatever assay they want to do downstream with their CTCs. I'm glad we have been recognized for all the hard work that we have put together over the last years, and I'm glad now it's ready to be used by the researchers to really make a difference in the cancer diagnosis and also monitoring of the patient over time.